Snowball Earth, evidence of surprisingly dynamic climate over 600 million years ago, Earth endured a period known as Snowball Earth, where nearly the entire planet was covered in ice. New research, however, suggests that even during this extreme freeze, the climate was far from static. A team led by Chloe Griffin at the University of Southampton has uncovered evidence of active climate cycles, including patterns resembling modern El Niño and La Niña. Events within remarkably preserved glacial sediments from Scotland, the Cryogenian period, and glacial records the Cryogenian period, spanning from approximately 720 to 635 million years ago, saw at least two major Snowball Earth events. The first, the Sturtian glaciation, roughly 717 to 658 million years ago, is the focus of this new study. Unlike most Cryogenian-era rocks, which are heavily eroded by glacial activity, the rocks found on the Garvalach Islands off the west coast of Scotland contain distinct, finely layered sediments. These layers were formed in a way similar to modern glacial lakes: coarse sediments deposited during summer melt and fine clays during winter freeze. The researchers identified approximately 2,600 annual sediment layers, providing an unprecedented record of climate conditions from this deep in Earth's history. This level of preservation is extraordinary, allowing scientists to analyze the thickness of each layer to reconstruct past weather patterns. Ancient climate cycles mirror modern phenomena. The analysis revealed 4 repeating cycles in sediment thickness, corresponding to known climate patterns. The most striking is a 4 to 4 5-year cycle, closely matching the El Niño Southern Oscillation, ENSO. This suggests that even during the Snowball Earth event, a tropical climate system capable of heat transfer between ocean and atmosphere existed, indicating the presence of at least partially open water near the equator. The remaining cycles appear linked to variations in solar intensity, further suggesting that the ancient climate responded to external factors in ways comparable to today. Debate over Snowball Earth severity. The findings contribute to an ongoing debate about how extreme the Snowball Earth conditions truly were. Some data support a completely frozen planet with minimal atmospheric interaction. However, sites like the Garvalach Islands suggest localized areas of open water and a more dynamic climate. The observed sediment patterns could also reflect short-term warming events caused by volcanic activity or asteroid impacts. The preservation of these ancient annual layers is unprecedented, offering a rare window into a period of extreme climate change and providing evidence that even under the most frigid conditions, Earth's climate systems were active and responsive. While the study acknowledges that the layers may represent only a brief period of partial thawing during the 59 million-year Sturtian glaciation, the findings challenge the notion of a completely frozen, inert planet. The evidence points towards a more complex reality, where even under extreme conditions, Earth's climate retained some degree of activity and cyclical behavior.